Okay, hello everyone. Today our talk is about the laws of indices, about numbers in IGCSE part. Okay, so here let's make a review for last lesson. We learned about multiplying and dividing, right? And we knew that here we have AMs times ANs. That means there's MA and there's NA, and we add it together, there's M plus NA together. Okay, so also for here we have some examples, right? Okay. So let's move into the next part about the brackets and zero index. Okay. So right here you can find here is AM's ends. Okay. So you can consider that there are like here is AM, right? There are M's in the bracket, right? And there's M's A. Okay. And after that you have N's bracket, right? So you can say your time is a lot of A and each bracket there are M's A indices. Okay. So here's our like N brackets total together. So for the A, we have M times N together, right? So for here, this formula equals to AM times N, okay? And also for this example, you can find here that is Y cubed fourths, right? So using the formula, we can say this like Y cubed times Y cubed times Y cubed. So the final answer is Y 12ths, okay? This is for this example. And another definition for indices is here, like NA zeros equals to 1. Okay, that is a basic definition. So don't double the y's. It's just like a definition or just like a laws, a basic laws in the IGCSE mathematics. Okay, so here we can set it is 7 zeros equals to 1 and 5x zeros equals to 1. And also for 5x zeros equals to like maybe 5 times 1. Okay, here is 5. Okay. And here is also another definition about indices is negative indices. Okay, so we just define the negative as a fractional number. Like here we have a negative n, and final answer is 1 over a n. Okay, if here are a over b negative n, that means we have to reverse the fractional number. It becomes b over n, and here's b over n a's. Okay, so like here, it has an example like 3 negative 2. That means we have to first put 3 2 or 3 square and we then reverse it becomes 1 over 3 squared. And the final answer is 1 over 9. Okay. And if we have 5x negative 3, we have to first reverse the x cube. It to form 5 times 1 over x cube. And the final answer here is 5 over x cube. And if here we have 2 over 3 negative 2, first we can reverse 2 over 3 and to become 3 over 2. And then we square it and it's 9 over 4, right? Okay, so the final answer here is for 2.25. Okay, so there are all the examples about negative indices. I guess maybe it's very important for you, and I hope you can just remember of this. Okay. So for fractional indices, maybe it's extension in IGCSE, but everyone has to make a basic understanding for this. Like here, we have a 1 over n's. So we can just put a squared n before a. Okay. So maybe here we have x a half, that means square root x. And if we have x 1 over 3, means x cube root. Okay, so here's for this. So if you have like 64 and the indices equals to 1 over 3, and the final answer is like this, and we can set that 4 times 4 times 4 equals to 64. So the answer here is 4. Okay, that is for fractional indices. Okay. So we have like another kind of fractional indices, like here a m over n, right? If we can first put a as or a square root n as a first beginning in the brackets, okay, and then we added the power of m after this, okay? So like here, if we have 27, like 2 over 3, we can first calculate 27 cubic root, okay, and here is 3. And then we can calculate for 3 squared, and the answer is 9, okay? So here, the answer equals to 9, okay? And here's some practice for you to solve this, okay? So you can just pause the video and trying to solve for these problems, okay? Give you several seconds for you, please. Okay, so if you are still have some question, you can just keep on going. And if you want to have more time to do this, you can just pause the video. Okay, so let's do together. Like first, a fifth times a cube. So we can use a formula before, right? That is am times an. It is am plus n, right? We have m's a and times n's a, and there's total number for a is m plus n, right? So here is for a 5 plus 3, and it's a a's, right? This is for the first formula right here. And for second, we can say is 2b cubed fourths, right? So we can say it's 2 fourths times b 3 times 4, okay? And here the formula is like 16 times the b 12. Okay, so every time please remember that the formula like AMS means like AM times n, okay? So here. And for 8x0, we said like for every number or even 0 equals to 1. Okay, every number's 0 power equals to 0 and the final answer is 1. So here equals to 8 times 1 and it's 8, right? And for the fourth formula, we can say it's 4 negative 2, right? So we can first to calculate right here, like we just made it 1 over 4 squared, and the answer is 1 over 16, right? This is the fourth formula right here, okay? And for 16, 1 over 4, we can also calculate this like this. We can just write down a fourth right here and the 16, right? And the answer is 2 because 4, 2 times together and it's 2 times 2 times 2 times 2, and the answer is 16, right? And for this, like we said before, like first we can calculate like here, calculate the cubic root, and then we have to square it. So that is 5 squared, right? So 5 squared equals to 25, okay? This is for the fifth problem, okay? And for the sixth problem, we can first calculate here is a negative in the power. So here is like maybe for 2 cube, okay? And the answer is 8. And here is a very very difficult problems we can solve together. We can say this is for an algebra part because we have some variables in this. But to just understand it here, we can just consider x as a number, but we didn't know the exactly number right here, okay? So you can set like here is like 12 and x fifths y squared, okay? And here is 3x squared and y negative 1, okay? So you can just first changing y negative 1 to become 1 over y, right? So this maybe seems to be very easy for you, maybe more easier, okay? So for here, you can find there's x fifths and x squared, right? So you can use this x fifths to over x squared, right? Because we have 5x on the top of the fraction number and 2x under the fraction number. So here using x fifths to over x2, that is x5 minus 2, right? And for 12, we can over 3, and the answer is 4. So it's 4x cubed. And here we have y squared and over 1 over y, that is for y cubed. So final answer here is for 4 times y x cubed times y cubed, okay? The answer here is 4 times x cubed, y cubed, okay? That is for the indices right here, okay? Okay, so we have just moving very smoothly to understand the laws of indices, but I guess here's still some questions for you. So just trying to make more practice after the lesson. I hope you can get a more clearly understanding for this. Okay, so next part is about surds. Okay, so what is surds? And then we can say here, surds like some irrational numbers. Like here we have like square root 2, square root 3, and square root 5. Okay. And we knew this exactly right in the first lesson of our total series, right? And here we had to calculate, maybe we had to make an operation between two surds. Okay, so right here we can find there's a multiplication rule. We have square root A times square root B. So we can first write down a total square root symbol right here, and then we put A times B under the square root symbol. Okay, so here is like maybe for square root AB equals to square root A times square root B, okay? And also for division rule right here, you can say it's like square root A over square root B. And the final answer is square root A over B, okay? That is for this. So like here, we can find some simplifying series problems like here. Like simplify the square root 75, okay? So we have already learned about the factors in the like last chapter, right? So we said like 75, there are some like root in this, right? Maybe for 75, we can just write down as 25 times 3, right? And then we can say like 25 it equals to 5 squared times 3, right? So we knew that the square root symbol is like a reverse operation for the square root symbol, right? So for square root 5 squared times 3, we can just first to put into the two different parts, like 5 square root times square root 3, right? So for this, square root 5 squared, we can say it's 5 because it's a very different or very opposite operations. So they just equals to the first or very first beginning value is 5, right? 5 times square root 3, okay. So this is for the final answer. We can say that this is how to simplify a surd, okay? And here is you can finding, we can also adding and subtracting the surd. Like here we have 3 times square root 2 plus 5 times square root 2. And the answer here we have total value is 8 times square root 2. We're just like adding the two numbers before square root 2. Like we have 3 square root 2, we have 5 square root 2, we can add them together. The total number of this is 8 square root 2, okay? Okay, also very easy. But here is a little bit difficult about the rationalizing the denominator. Okay, so how to rationalize this? Like here we have an example like 6 over square root 3. Okay, so for this problem, we maybe want to make this part to become a real number. It becomes like more easier for us to understand it. Okay, so maybe here we can know that because like 3 square root means we are just dividing a 3. So if we want to make square root 3 to become a maybe for a real part, maybe for integers, we can say we have to times the square root 3, right? So here we can letting the upper for the fraction number and the like downside for square fraction number, we can both times square root 3, right? So here we can say 6 times square root 3 is 6 square root 3, and square root 3 times square root 3, and the final answer is 3. So the answer here is 2 times square root 3, okay? That is for how to rationalizing this, okay? Okay, and for conjugate, and maybe this is a little bit difficult problems. Okay, we have a plus square root b, and like here we have 2 over 3 plus square root 5. So we just definite the conjugate for the a plus square root b as like a minus square root b. Okay, so if we have like the 3 plus like square root 5 like under the maybe for the fraction number, we can just using the conjugate to times it. Okay, so we can just count like to change this formula to become 2 times 3 plus 3 negative or 3 minus square root 5, and under the fraction number is 3 plus negative 5 times 3 minus negative 5. Okay, so why we have to do this? You can just find this equation, you can just like make it simplify, you can just expanding the brackets, right? First 3 times 3 is 9, right? And 3 times negative square root 5 is negative 3 square root 5, and like square root 5 times 3 is positive 3 negative 5, and square root 5 times negative square root 5 equals to negative 5, right? And here, our fraction number is 6 minus 2 times square root 5. And you can find they equal to each other, so they can like delete them. And the final answer is 4, and this is 6 minus 2 times square root 5. Okay, that is for this. Okay, so if we have for this number, we can set maybe right here, you can find this number switch it from 3 plus square root 5 to 4, right? So we're just using the formula like a squared like minus b squared equals to a plus b times a minus b. So if we add an a minus b after this, make a product for this, and you can find for this, it can become an integer. Okay, so this is for the total process for this, and you can just divide it by 2, and it's 3 minus square root 5 over 2. Okay, that is for how to rationalizing these problems. They are very important. Okay. Okay, and here are some practice for you to do after classes. Okay, I'll give you an answer right now. So if you want to try on yourself, you can just pause the video. And if you have some like interest to solving problem, you can just make a discussion with me. Okay, so I'll just give you an answer right now. So first problem here simplifies this. The answer is 2 times square root 3. And here we can set like square root 200 minus 3 times square root 2. And the answer is 7 times square root 2, and the answer is 1, and the answer is 2 times square root 5, and the answer here is 2 plus square root 3. Okay, so that's for today's lesson. I hope you can just learn from it and have a very interesting journey when you're learning for the surds and for the indices. They're very important and basic knowledges in numbers part. Okay, so that is for today's lesson, and hope you can just understanding this. So maybe let's see you next lesson, please. Okay, bye. See you next time.